Hey guys, welcome back to the series Java Full Stack Made Easy. So in the previous session, we spoke about uh, loops, right? So the last thing that we discussed was about the difference between a while and do while loop. And I told you in this session, we'll be discussing about arrays. That is going to be a very interesting concept. So let us understand what exactly arrays are in Java and why do we use arrays, and we'll also compare these arrays with list. So whenever I compare arrays with a list, people say that list is better than arrays. We will also see whether list is truly better than array or not. If list is truly better than array, why after so many versions of Java we are still using arrays? Why not list directly, right? So let's go ahead and understand what exactly arrays are and in what situation arrays will be used. So by definition, arrays are what? First of all, it's a class type data type, and array is a collection of elements of same data type. Okay. So by definition, what it is? Collection of elements of same type, same data type, right? So when we say a collection of elements of same type, there are two type of collections actually. One is homogeneous collection, next one is heterogeneous collection. A homogeneous collection is one where the collection is of same type of object. Heterogeneous collection is one where it's a collection of different type of objects. So arrays can be considered as homogeneous collection. Now imagine a situation where I want to store the marks of 10 students, right? So marks of 10 students, obviously it will be integer marks. So I'll be creating it as marks, and it is for 10 students. So what I will be generally doing is I'll say students marks 1, 2, 3, 4, 5, 6, because we know that variable names cannot be repeated, but a meaningful name of a variable has to be given. So I'll be giving the variables like this. So for 10 students, I keep on giving this. So what do you think? Like I should be going for writing all of this like 5 marks variable is better, or on one line itself I can say int marks is equal to new integer of 5. So if I do this at time, it's similar to creating 5 or 6 different arrays. It's same to that. So whatever number of variables you want, that number of elements you can create in an array. It is as simple as that. Okay. So instead of writing all this line of code, just write this one line of code indicating that I want to block 5 memories of integer type. And because it is an array, so let's try and access that array here. What I'll do is I'll simply create a method. So by now you should also be able to understand the concept of methods and all, so that even in future it will be helpful for you. So I'll just create a method and I'll call it as a display method. Okay, and I'll start and end the body of this display method, and also I'll invoke that display method here. So in previous examples also I've shown you how do we create the object and how do we call the method. So if the method needs to be called only once and the object reference is not required, one liner can be used in Java. Okay, so we will again see this one liner in details in our later sessions, but as for now, since I don't need any reference, this is also a way of calling a display method. So traditional way which I have shown you up to now is this, right? Demo1 d1 is equal to new demo1, and then we used to call d1 dot display. So this is something which I have shared before. So writing these two lines is same as writing the above one single line. So because this is short and sweet, so I'm opting for this approach rather than going for this approach. Okay, so obviously there is some advantage of creating this and there is some advantage of creating this. There are certain limitations of doing this, certain limitations of doing this. So based on the scenario, we pick up which one should we go for. So we will discuss this later. As for now, our focus is on this array. So as of now, an array of 5 elements is created. So arrays are class type data types. We know that the class type data types are not simple values. It is only the 8 primitive types in Java which are simple values. So now what I'm doing is I'll be checking out how many elements are reserved. It is same as, let's go to the drawing board and understand what I have done. So by saying an integer marks, okay, array is equal to new integer of let's say if I, by doing this, see here I have written a different syntax, and there I have written a different syntax. You can see that I have written it here, or I may write it here. Both are valid in Java. Recommended way is this itself, okay, but both are valid. So by doing this, what I am doing is this: I am reserving 5 memory blocks of type integer. This is 1, 2, 3, 4 and 5. So instead of creating 5 variables separately, I have created just one array, which is same as creating this 5 variables. So each variable, each index in an array will be identified by its index position. Array indexing begins with 0. So it will be 0, 1, 2, 3, 4 and 2, 3 and 4. So this is our array, and by default as of now it contains nothing, right? So if it contains nothing, then it is 0 by default, because it is an integer type of array. Array as a whole does not contain any default value. The default value for an array as whole is null, because all class type data types are null by default, but the elements will hold 0 by default in it, okay, because elements within that is int, primitive type, right? So that's why it is 0 by default. Let's see that. So I'll go here, and then I'll do a system.out.println, and then I will try to print what is marks of 0 first. Okay, likewise I can go for marks of 1, 2. Randomly I'll go for marks of 2 and marks of 4. Okay, so these are the 3 elements that I want to print from an array and want to see what is the result in there. So when I run this, you can see that all of the elements are giving me 0 itself. So that actually proves us that when we create an array, so the array elements will get the default value based on the type of that array. So if this array was of type string, it will all be 0. If this array is of type float, it will be 0.0. If this array was of type boolean, then these elements by default will be false, right? So that those are the things that we have already learned before. So let me just put this into the repository for your reference. How do we actually create an array? Where do we create an array? And how do we access the elements of that array? How do we call this method display in here? Okay, so let's go to the repository and push it there. Now this is our session 10. So I'll add a day 10 repository here. So let's call it as day 10 demo 1 array. All right, so let's put this first demo in here. And now very first thing I'll discuss about is array having the default value. See, if I don't initialize this array, now this is an instance variable, right? So as a whole, it's an instance variable, so it should have some default value. Let's see what is the default value in that. Now what I'm doing is I'm trying to do a marks of 0. Marks of 0 is not there, right? So this marks is actually null now. Okay, marks is null. So let's check what is there in marks first. So when I check that, it says null. Because of what? Because it's a class type data type, so it will be null by default. Now I want to access something on a null object. So when I'm trying to access something on a null object, at that time I get a null pointer exception. Okay, they should always remember that there is a chance of getting a null pointer exception in an array, and there is a chance of getting a array index out of bound exception as well. So you have to be very careful when you are dealing with the arrays. There is a chance of getting a null pointer exception if you don't initialize the array, and if you access the element which is not initialized. That is, if I try to access the element 6 here, okay, element 6, that means at least at the position 5. So 5th position we don't have, right? So up to 4 only we have reserved the memory. If the memory is not reserved for the 5th element, but memory is reserved for marks, at that time we will not get a null pointer exception. We are not pointing to a null memory. Memory is allocated to marks, but we are going beyond the memory that is allocated to this. So in that case, we are going to get a array index out of bounds exception. So do remember these 2 points, that we might get into a null pointer exception, or we might get into a array index out of bounds exception. So I'll give you the example. If we do this, at that time we are going to get a array index out of bounds. So these are again the questions that will be asked to you in your OCJP, Oracle Certified Java Professional. So let me save this and put this into a repository again as demo 2, where you will know that if you try to access an element which is beyond the boundaries of the memory that we have allocated, you get the array index out of bounds. Okay, and because array is a class type data type, if we don't initialize anything to an array, it will be null, and if we try to access any element on a null object, we get a null pointer exception. So this is a scenario where we will get a null pointer exception, because it is null and we are trying to access a element on a null object. So let me give you this as well, so that when you are practicing it, it is easy for you to access these files and then get to know when we were getting a null pointer exception and when we were getting a array index out of bounds exception, and when we were not getting any error and we were able to access the elements. So let's call this as null pointer. All right. Now one more important point about the array. So I was accessing this array with its index position. If I want to access everything into an array, what I can simply do is I also have some predefined methods available with the arrays. Like you can see, there are so many methods available with this array, and one commonly used property with the array is length property. Okay, you can see that there are methods available with this, because it is a class type data type, so it will have the methods, and these methods are actually not the methods of array class. These are the methods belonging to the object class. That's why you can see that there is object written here. So wherever you find that the object is written there, it is actually a method belonging to the object class, which is a parent class for all the classes in Java. And this length method belongs to an array. So sorry, not method, it is a property. Okay, so length property belongs to array, that tells me what is the size of that array. As for now, again, there should be a null pointer exception, because I am trying to access a length on a null object. There will be a null pointer exception, and if I initialize this to some 5 or something, so at that time I'll get the length as 5. So let's run this, and we are getting the length as 5. So this example, once again I'll put this into the repository, so that we get to know that there is a length property available in array, and that gives us the length of the array. Okay, very useful concept, arrays. Now one more important thing with the length is that we can use the length property and also iterate over the entire array. That is, for how do we do that? For int I equals to 0, I is less than the array, which is marks dot length, and then I plus plus. So by using a loop and the length property within a loop, we will be able to iterate over the entire array. So marks of I in the first loop will be 0, so it will give me marks of 0. Second loop, it will be 1, so it will give me marks of 1. So I'll just say system.out.println here, value of I. Okay, so value of I in each loop will be changed, and that value of I will be added here. So you can see this here, value of I is 0 first, then it is 1, it is 2, 3, 4. And since nothing is initialized into this array, all of them is returning me as 0. So that's why we get, that's what we get. Similarly, if we initialize something into it, like what, like let's say I want to initialize something like this, marks of 0 equals to some 5 or something, and likewise I'll say marks of 1, marks of 2, rest all I'll just leave it as it is. Marks of 1, let's say 55, marks of 2 equals to 15. So 3 values I have initialized, other 2 values I have not initialized, so 3 values I should get, other 2 values should be 0. So I'll be getting everything. So I0 is 5. You can see that is 5. I1 is 55. So that's what I'm getting. I2 is 15. I2 is 15 is what I'm getting. I3 is 0. I4 is 0. That's because we did not initialize that. So this is one way of creating and initializing an array and also iterating over the array. So let me add this as well into the repository. So this is my demo file. Let's call it as for loop with array, that is iterating over an array, entire array. This is what we used to do before Java 1.5. Java 1.5 came up with one more special loop called as enhanced for loop. If you remember, in the previous session I told you about an enhanced for loop which is specially created for arrays and collections. So let's see how an enhanced for loop looks like. An enhanced for loop takes 2 arguments, whereas a normal for loop takes only normal for loops takes 3 arguments. Here it takes only 2 arguments, and normal for loop is separated with a semicolon, whereas this enhanced for loop is separated with a colon. The second argument is an array name of an array on which you want to iterate. The first argument is a variable of same type of an array. They create a variable which is same type of array. So what is the type of array? Int, right? So that's why I'm creating a variable of type int. And what happens in an enhanced for loop is that every loop it will automatically understand what is the length of that array, and in every loop it will get one value from here and put it into a. Okay, so let's just put this a and get all the values. So 5, 55, 15, 0 and 0. So 3 values I have initialized, 2 values I have not initialized, so that's why by default they are 0. So this way we can make use of an enhanced for loop with an array. So let me put this also into the repository, how an enhanced for loop can be used with the array. So this is my demo 6. This is called as enhanced for loop. In some programming it is called as the for each loop. In Java we call it as enhanced for loop. Okay, you can call it as a for each loop also, does not make any difference, but that is what we call in Java enhanced for loop. Now declaration of an array in Java has various other ways also. What I can do is I can simply just go ahead and even write this 3, 6, 8, 7, 9. So what happens internally is that it is going to create an array of 5 elements, and those 5 elements will be initialized. That means you can see that 5 values I have given. So 0th value will be holding what? 3, 6, 8, 7, 9. So it will be 3, and this will be 6, this will be 8, and this will be 7, and this will be 9. So that way we can initialize the array. So let's iterate over it and get the elements, and that will actually prove you that all the values are initialized. So I can do that. You can see that 6, 7, 8, 3, 6, 8, 7, 9. So you can pick up any element also. So I'll pick up element here. Let's say marks of what I'm picking. Marks of 3 is what I want to pick. So if you check marks of 3, what is it? It should be 7. So marks of 3 is what I want. So marks of 3 should be 7. If we get 7, so whatever we have analyzed is all correct. So marks of 3 is 7. So whatever we are analyzing is all correct. So this is another way of initializing the array. There are various different ways of initializing arrays in Java. So that can be your question in OCJP, the different ways of initializing arrays in Java. Initialize an array. So this is a shortcut way of initializing the array. Create and initialize it at the same line itself. Okay. So now you might see some weird syntaxes combined, like suppose I might use something like this, new integer of. So this is valid syntax. Okay. For array initialization, this syntax is also valid, where you already give new int and you then give the elements. It is valid. But if I give something like 5 here, it will not be valid, because I cannot decide that it is 5 and then initialize it. So if I don't give it, then it is fine. But if I give any size there, it will not be valid. So you should make sure that these things are taken into consideration when you see the array and somebody asks you to predict the output of the array. Now next point is arrays cannot be resized. Okay, so that's an important point, that says arrays cannot be resized. So let's go ahead and see whether the arrays can be resized or not. So what I will do is, in display method, time being, I'll just remove this, and I will check what is the size of the above array. What is the size? How do we get to know the size? We get to know the size by using the marks.length. So let's save it and run. So what is the length now? 5. What I will do now is, let me call this as old length. Okay, plus marks.length. What I will do is, I'll say marks is equal to the same marks I'm trying to access, new integer. Marks is equal to new integer of 7. So I'm trying to increase the size of the array. So I'll call this as new length, and I will check what is the length of the array now. So new length, let's save it and run this piece of code and check. So now it says old length is 5, new length is 7. So it is not giving us an error. It is also executing the piece of code. But what we have learned is arrays cannot be resized. But here in this example, arrays are resized. So what is the problem here? So let me first put this into the repository and then tell you what is that all about. So this is my demo 8. Array resize. Arrays cannot be resized. Okay, but what I have done, let's understand what exactly I have done in that program. Did I really resize the array? So see, arrays cannot be resized. This is half statement, but the same reference variable can be used to refer to an entirely new array. So what do I mean by that? See, what I am doing here is marks is equal to new integer of 7. I am actually using the same reference variable marks to create a new array of 7 length. This array is not resized. That means I am not adding 2 more elements here. What I am doing is, this marks which was pointing to this memory before, this reference will be gone. This marks will be referring to a new memory now. So when I refer that to a new memory, obviously now the new memory does not have any elements into it, right? So if there are no elements initialized into this new memory, what will be the default one? Defaults will be 0. So let's see whether this is happening, that is whether we are increasing the size of the previous array or we are creating a new array by running our program. If we run this program now, iterate over this marks here. So I'll try to iterate over the marks here by using an enhanced for loop. So now, just now itself we have learned about the enhanced for loop. How does it work? It is separated using a colon. Second argument is the array name. First argument is the name of a variable of same type of array. And let's just do a system.out.println and then print a. So what I'll do is, I'll just use a system.print, not println. Same way, before this initialization in the old array, I'll print the same thing. Because it's a local variable, the variable names can be repeated because it is restricted only within this for loop. Okay, so that's why I can repeat that a here. Now this also print, and at the end one print line I will give, and I'll say new values. Okay, so below one will be new values, the above one will be the old values, and it will be printed on the same line because I'm not using a println, I'm just using a print statement. So let's run this and see what happens. So you can see old length is 5, that's fine, and the values, old values. So what I will do is, in the old value I'll also add a space and comma so that I can see the values properly. Here also I will add a space and a comma so that I can see the values properly. Let's save it, run it and see. So you can see that old values were 6, 8, 3, 6, 8, 7, 9, whereas in the new array everything is 0. So when everything is 0, what is actually happening is, the previous reference is gone, this array is lost in the memory. Now marks is pointing to a entirely newly created memory. So that this statement, now what we have written, is proved correct. Arrays cannot be resized. but the same reference variable can be used to refer to an entirely new array, and in that case the previous elements will be lost. Hope this is clear to you. Now let me put this demo again into the repository. This is demo 9, array resize 2. Okay, so arrays cannot be resized, but the same reference variable can be used to refer to an entirely new array. Now we have talked about a lot of things with an array, that is how do we create an array, what kind of exceptions we can get with an array, whether it is array index out of bounds or maybe a null pointer, what is the length property of an array, how do we iterate over an array using a for loop, and then how do we iterate over an array using an enhanced for loop. Then we have discussed about what initializing an array, the different ways of initializing an array. Then we have seen array resizing, whether it can be resized or not. How do we make use of a same reference variable to refer to an entirely new array. And in the demo one we have seen why should we make use of an array, right? That is like in when we want to create multiple variables like this, instead of creating these variables, imagine if these were 100. I cannot go ahead and create 100 variables, right? In one single line I can create and initialize all of them to 0, or I can just say int marks is equal to, then create the flower brackets and initialize 100 values there. So easier way is available to us. It's nothing but reserving 100 integer memories, right? So now let's understand. We know that arrays obviously collection of similar type which holds the values like variables, and we also know that there is a concept called as list available with us, right? So whenever I talk about the arrays and the list, whenever I compare the list, or whenever I ask people about whether arrays are better or list is better, I always get the answer as list is better than array. And whenever people tell me that list is better than array, my question will be one: if list is better than array, we have found out that list long back, right? Why didn't they remove this array concept completely from the programming, right? So they should have removed it. Let's now understand what is better, whether array is better or list is better. See, what happens in a list is, suppose I'm creating a linked list. So we know that in a list there are two parts. One is the data part of the node, and another one is the address part. So each node will hold the data and also the address of the next node. So what I have now is let's say I have 3 nodes as of now in a list. So what I'm drawing is a list. So let's say this, and let's call this, let's say the value that is stored into this node is, let's call it as 10 is the value stored, and here the second one stores 20 and the third one stores 30. That's what are the values that are stored into a node. And the second one, the second part holds the address to the next node, right? So let's say the address is 101, and here the address can be 500, and here the address can be 200. And if I want to insert something in here, so now this list is like this: 100 is pointing to its next element, 500 that is pointing to its next element, 200, right? And if it is the last element, then it will be null, right? So it will not be pointing to anything if it is the last element. So let's remove the address from here. Now what I want is, I want to insert an element maybe here. Okay, I want to perform an insert. So when I insert an element here, what actually should happen is 101 is actually a address of this. So I'll be writing the addresses here. So this is 101, okay, and this is 500. So it is holding that addresses of these nodes. Okay, that's why 500 is this is pointing to the next element, and this is pointing to the next element. Suppose if I want to insert something here, so what should I do? First of all, I should create a node here, and this node has some address. Let's say the node address is maybe 111. So if the address is 111 for this, I want to insert it here. So 500 should be removed from here first. Okay, and let's remove that 500 here. So an insertion should happen. So for insertion, this will be gone, and this should store the next element address, that is 111, and this node that I have inserted will have the data part, and also now this will have the next node's address, which is 500. So this is how an insertion happens into list, right? I hope this is clear to you, how we insert the element into a list, because list can be resized, it can grow, it can shrink. You can grow a list, that means you can insert the elements there, or you can remove the elements from a list, but in an array it is not possible. Okay, and if I want to iterate, if I want to go to this element, suppose I want here I have stored some value as 40, so I want to get this value 40 into a list. What I have to do is I have to go to the head of this node, and then I have to go to the next element, then I have to go to the next element, there I will find the value. So this is how we get the values in a list. I have to traverse from one element to another element. The advantage of this list is that it can grow, it can shrink. Arrays cannot grow, arrays cannot shrink. So let's see the design of an array and understand what is the advantage of an array and why it is still being used. So if this is clear, you can take a photo of it and later you can refer it. I'll just remove it from here. Okay, so you can pause the video, take a photo of it, and then understand it. You can go back to some frames, and then again understand the list. And you can also watch my videos into 1.5x speed if you feel that what I am explaining is bit slow, because I cannot talk that much fast, right? Now coming to the arrays, what is the design of the array? First of all, we say that arrays cannot be resized. So once these arrays are defined, see 1, 2, 3, 4, 5. So I'll take an example of an array initialized with 5 elements like the one that I have discussed. So it will be int array marks is equal to, so what values I gave here, the same values I'll take, 3, 6, 8, 7, 9. Okay, 3, 6, 8, 7, 9. So what happens is each of these elements obviously is given a index position, but what happens is the index position is for us, but for the machine it's not the index position. For the machine it is the memory address, right? So the memory addresses for each of the element will be given. And one important point you should note is that arrays will have sequential memory. Okay, that means it will have a memory in a series. Now what do I mean by that? First we should understand that what is the type of this array. The type of this array is int. We know that int is equal to 32 bits, that is 4 byte. Okay, so 32 bits is 4 bytes. Each memory block is of 8 bits. Okay, whenever we are reserving the memory, 8 bits equals to 1 byte, so that is what we have to reserve. So now if this array starts with, suppose if it is starting with 101, if the first memory here is 101, this is the memory I am drawing here. Okay, then the second one should be what? The next available memory. So 101 will be used, 102 will be used, 3 will be used, 4 will be used, 105 will be the next available memory for us. Likewise, we have to keep going, and then 109 will be the next, 113 will be the next, then 117 will be the next memory address available, because array allocates the memory to the element sequentially. Okay, and at the time of creation of an array itself, the memory is initialized. Okay, it's not happening dynamically. We don't dynamically initialize the memory. So this is how the memory architecture will be. And now in an array, if we want to traverse to any element, what we do is we generally write it like this: marks of, if you want to go to marks of 3, you directly go to marks of 3, right? So in a list, what happens is you have to go to the head of the list, then you have to go to the next element, then you have to go to the next element, then you have to go to the next element. Whereas in array, you don't need to go to the next element. Now, why is that? Let's understand that with some example here. So I know that I'm creating the array of what? Of type int. That means the memory capacity is 4 bytes. And what is the start position? What is the start index? 0th index. What is the memory there? The memory given there is 101. Okay, that's fine. What are you searching for? You're searching for marks of 3. So marks of 3 is what you're searching for. And then how many, what type of array it is? It is of type int. Okay, so then what we have to do is we have to simply say into 4. So how much is that? 4 into 3 is 12, and 101 plus 12, right? So 101 is the initial value. So 101 plus 12. So what is the result? 101 plus 12 is 113. So at the third position of an array, is the memory address 113? Yes, the memory address is 113. You can do that with any of the element of an array. Let's say I want to search for the element 2 now. So if I want to search for the element 2, I have to get the initial value, that is 101. Okay, and then what I should be knowing is what element I want to go for. I want to go for the index position, IDX position into what we do is size. So index position, what we are searching, the index position 2 is what we are searching. So 2 into what is the size? The size integer is of 4 bytes. So that is the size, 2 into 4. And then 2 into 4 is here 8. 101 plus 8 is how much? 101, that is the initial value, plus 8 is how much? 109. So you go to the position 109. So advantage of this sequential memory is that you can jump to any of the element into an array. So this is the memory architecture of an array. How exactly how fast it can take you to any of the element. Even if you want to go for the 100th element, if there was some 100th element available for you, so what you simply do is 101, that is 100 into 4, right? 400, and the 400 plus 101 it will be. So 400 plus 101 is 501. So 100th element has to be at the memory address 501 because it allocates the memory sequentially. Because of this sequential memory allocation, the iteration, that is picking up the elements from an array, if you want to access the elements of an array, access will be given to you faster comparing to the list. So arrays are fast comparing to a list. That is why we still use arrays, not list in all the cases. List is dynamic, but arrays are fast. So depending upon the scenario, you pick up a list or a array. Because of the sequential memory allocation itself, array does not allow resizing. Why is that? That is because, see, if somebody has initialized the array like this now, and some other variable has already occupied the next available memory, and if you have the next available memory as 200 and you want to resize the array and give the next element here, resize it and give the memory as 200, the entire logic of retrieving an element from an array will fail. You cannot apply the logic now, right? Because this is not sequential. So arrays do not allow resizing because of the memory sequential memory allocation. Why the same reference variable can be used to refer to an entirely new array? Next time when you are creating the new memory, again sequential memory will be used. Okay, so I hope the concept of arrays is very much clear to you now. How exactly arrays are created behind the scene, why arrays cannot be resized, and how do we create the arrays, the advantage of array over list, why arrays were not removed completely from programming. So the conclusion is that whenever you know the exact number of elements, always go for arrays. If you don't know the number of elements, then you can go for a list. For example, if I know that in a pin code there will be 5 numbers only, then in such cases where I know the exact number, or maybe let's take an example, I have a classroom where there are 30 students for sure. There will be no extra students allowed, there will be no less students than 30. Then I will create an array rather than going for a list. If I don't know the number of students in a classroom, it might grow or it might shrink. At that time I can go for a list rather than going for a array. So depending upon the scenario, we pick up either the array or we pick up the list. Hope the concept of array is pretty much clear to you, and also I hope that the concept of enhanced for loop is clear to you, and the creation of an array, how do we initialize the elements to an array, is also clear to you. I'll not increase the length of this video much, but in the next session we will talk about the string class methods, and we will be using a lot of array from now onwards. Okay, so if there is any doubt regarding this arrays and all, you can ask the question into the comment section. If you are liking in the series, please subscribe to my channel. That will motivate me to create more such contents for you. See you in the next video.